The last type of factoring is called a quadratic type. So normally when we factor quadratics, we have something squared, like x squared, and then something in x, and then your constant term. Now, there are times that we end up with something that looks sort of like it, but not quite. And that's what we see here in number 15. We have x to the fourth minus 5x squared minus 24. So what we're going to do is we are going to let w be x squared. Okay, so I'm going to substitute this into the problem. So that doesn't change the 24, but that does change it. Instead of 5x squared, it's just going to be 5w. And instead of x to the fourth, it's going to be w squared. Okay, so I'm just making that substitution. And now I can factor this. That's just one of our really easy factors, okay? W and w. Got to be opposite signs. I'm looking for factors that multiply to negative 24 and add up to 5. So negative 8 and positive 3. So that's great. That's factored. But remember, there was not originally a w in this problem. It was an x squared. So now we're going to substitute our x squared back into the problem. And we have x squared minus 8 and x squared plus 3. So what this is just kind of a way to force it into something that we can factor, and then we substitute back to get what it's supposed to look like. So let's take a look at number 16. It's got a very similar setup. We are going to let w be x squared, which that doesn't change the 36, but that changes the x squared to a w, and it changes the x to the fourth to a w squared. So now we're just going to do our umbrella factoring. So 4w and 4w. Signs are going to be the same and both negative. And we umbrella factor and we get, it's like 144, isn't it? Yeah, 144. So I'm looking for factors of 144 that add up to 25. Yeah, that's what I'm looking for. Yeah, can't remember anything. All right. Yeah, we can list all of our factors if we have to, I guess. So 141 and 144, 2 and 72. See, these have to be the same signs, don't they? Let me think. All right, so 3 and, let me think, 48. 4 and 36. 5 doesn't work. 6 and 24. That doesn't work. 7 doesn't work. 8 and 18. 9. Oh, 9 and 16. I think that's it. Yep, 9 and 16. All right, and then we had too many 4, so we have to divide. Okay, so finally, this factors into 4w minus 9 and w minus 4. Now, remember, I'm just going to erase this so I can keep writing. I've got more stuff to do here. This was not a w problem. It was really an x squared problem, so we're going to substitute back in, and we get 4x squared minus 9 and x squared minus 4. Which is fantastic, but we are not done here. These are both differences of squares, so this can be factored into a plus minus. So the square root of 4x squared is 2x, and the square root of 9 is 3. I need to make more space for that. So we have 2x plus 3 and 2x minus 3. And then this one can also be factored. It's a difference of squares. So another plus minus. The square root of x squared is x, and the square root of 4 is 2. So there we have it completely factored.